December 12th, 1996, Vermilion Cliffs, Arizona, and 6 birds with 3-meter wingspans stepped out of transport crates into a cold desert morning, each one carrying a numbered tag on its wing and the full weight of a 72-year absence on its back. Within minutes, not hours, minutes, they found the thermal rising off the canyon wall, locked their wings into that enormous 3-meter span, and lifted without a single effortful stroke, the way something lifts when it already knows the air. I'm Dr. Raymond Finch, and I've spent 40 years documenting what ecosystems look like when their key pieces go missing, and what they look like sometimes when those pieces come back. A condor's wingspan reaches 3 meters, wider than most rooms you have stood in, and that span is not decoration. It is a soaring engine built to cover 250 kilometers in a single day across Broken Canyon country. Wildlife biologist Parish, stationed at the Vermilion Cliffs release site for the Peregrine Fund, was the man with the field notebook that morning, and he documented something no predictive model had accounted for. All 6 birds turned north, away from the food cache the recovery team had positioned, and soared completely out of visual range before the first hour had elapsed. Now, think about what that means for a moment. The last wild California condor had been documented over Arizona skies in 1924, and the canyon had simply continued without it for 72 years, running a broken version of the biological system it had always depended on. That system, the carrion cycle, is not poetic, it is functional plumbing. Large carcasses decompose, pathogens spread through soil and water, and without a scavenger powerful enough to consume bone and neutralize anthrax and botulism in its gut, the landscape accumulates biological debt across every dry season. By 1987, the entire California condor population on Earth had been reduced to 22 individual birds, a number so catastrophically low that the U.S. Fish and Wildlife Service made the decision to capture every last wild specimen and remove them from the landscape entirely, placing the survival of the species inside a captive breeding program. Here is where the data stops being data and becomes something else entirely, because what the recovery team released over the Grand Canyon in December 1996 was not simply a bird. It was the first field test of whether 9 years of captive breeding, behavioral conditioning, and lead ammunition politics could actually produce an animal capable of choosing its own geography. And those 6 birds answered that question inside 60 minutes, by flying north into country they had never once seen, following a navigational instinct that 72 years of absence had not erased from the species. But Parish's field notes from that morning contain a detail that changes how you read everything that came after, and we are going to get to it, because it tells you something about what this recovery actually cost, and why the canyon's carrion cycle is still not fully repaired today. Stay with us. What did Parish's notes reveal? Emmanuel Parish's notes do not open with triumph. They open with an inventory, a quiet, almost clinical accounting of what the landscape had become in the 7 decades before those 6 animals crossed the Vermilion Cliffs and vanished north into the plateau. Every visitor standing at the South Rim in the early 1990s saw exactly what they expected wilderness to look like: vast, layered, ancient, undisturbed. The silence read as health. It was not health. It was the silence of a system running on reduced capacity, like an engine missing 1 cylinder that no one had bothered to diagnose. Baseline surveys from that period documented carcasses accumulating on the canyon floor: deer, bighorn sheep, mule, decomposing on schedules that a functional scavenging network would never have permitted, their tissues releasing lead and pathogens back into the water table, rather than being neutralized and recycled upward through the food chain. Turkey. Vultures were doing what they could, and what they could do was partial, because a 3-meter wingspan and stomach acid capable of neutralizing anthrax and botulism is not a feature that evolution duplicates. The vultures handled soft tissue, the deep processing, bone, marrow, the pathogen-dense core, when unfinished, accumulating across the plateau in ways the surveys were only beginning to measure. This is the part that made me stop and reread the field notes. The dysfunction was invisible precisely because the animals that would have made it visible were gone. You cannot see an absence. You can only measure the accumulation it leaves behind. The geographic record tells you where the collapse originated, and it does not tell a comfortable story. In Baja California, the last confirmed breeding pair was documented in the mid-1980s. A coastline that once held seasonal nesting colonies across 400 kilometers of Pacific shoreline went silent within a single generation. In the transverse ranges of Southern California, the count had fallen to fewer than 9 wild individuals by 1985. Not enough genetic diversity to sustain a single breeding season without direct intervention. Across the species' historic range from British Columbia to the Baja Peninsula, 1,000 kilometers of Pacific flyway had been extirpated within 40 years. The continental sky simply stopped containing them. Along the California coast north of Big Sur, nesting ledges that survey teams had photographed in the 1950s stood empty by 1980. The rock unchanged, the animals gone, the thermal columns rising into an unoccupied sky. By January 1987, the count reached the number that every conservation biologist who worked that decade still remembers as a specific weight: 22 living California condors, every single one of them removed from the wild and placed in captivity. The wild population reduced to exactly 0.22 animals. That was the entire living reserve of a species that had soared over North America for 10,000 years, processing carcasses across a continent, and now existed entirely inside 4 breeding facilities in California. Chris Parish, stationed later at Vermilion Cliffs for the Peregrine Fund, recalled reviewing those 1987 census figures and recognizing that the number was not a low point on a trend line. It was a geometric threshold, a population standing at the precise boundary where one bad breeding season, one contaminated carcass, one disease event could have removed the option of recovery entirely. You are wondering, at this point, how a species gets from 22 captive animals in 1987 to 6 soaring north over Arizona by 1996. What the captive breeding program actually produced, and what it cost to produce it. The data from those 9 intervening years answers that question, and it changes the scale of what Parish documented at the release. Stay with this. We are going to show you exactly how that number moved and what it required to move it. The number that moved was not the number anyone wanted to talk about. Before one feather touched Arizona air in 1996, the United States Fish and Wildlife Service and its partners had committed more than $35 million to a program built around a problem they had not yet solved. The San Diego Zoo and the Los Angeles Zoo had done what they were funded to do. They had produced birds carefully, painstakingly, over 9 intervening years, building a captive population from 22 individuals until release was biologically feasible. That part worked. What $35 million could not purchase was a clean landscape. The lead contamination that had dismantled the population in the first place was still present in every gut pile left by hunters using lead ammunition across the Condors' foraging range. Untouched, unlegislated, waiting. Chris Parish, wildlife biologist for the Peregrine Fund, stationed at the Vermilion Cliffs release site, understood this gap before the field data confirmed it. In the months following the December 12, 1996 release, he began drawing blood from reintroduced birds at regular intervals, building a toxicological record the management plan had not required, but the landscape made unavoidable. Here is where it gets interesting. What Parish's blood sampling returned was not an outlier or a worst-case scenario. It was a pattern. A significant portion of the monitored population showed lead levels high enough to require veterinary intervention, not once, but repeatedly across the first recovery years, with some birds requiring chelation treatment multiple times before a single breeding attempt. The birds were not failing the program. They were doing precisely what 10,000 years of evolution had shaped them to do: locating carrion, consuming it completely, cycling the landscape's biological waste. They simply could not know the ammunition had changed. You are probably forming a reasonable suspicion right now that someone, somewhere in those 9 years of preparation, should have resolved the ammunition question before the first bird left the pen. That suspicion is correct, and the answer to why it was not resolved is more uncomfortable than any field data Parish collected. Stay with this, because what the ammunition debate actually produced, and how long it took to produce it, reframes everything you think you know about how conservation policy moves. The voluntary non-lead ammunition program in Condor Range did not arrive in 1996 with the birds. It arrived in 2005. 9 years later, after hundreds of documented lead poisoning interventions had accumulated into a data record that agencies could no longer contextualize as acceptable loss. Arizona moved first, and it moved voluntarily because mandatory regulation had stalled on jurisdictional and political opposition for nearly a decade. The gap between the release date and the policy response was not a bureaucratic footnote. It was 9 calendar years during which reintroduced birds absorbed the same toxin that had reduced their population to 22 survivors in the first place. $35 million solved the supply problem. The condor's own biology identified the demand problem. By returning to a poison landscape, absorbing the data personally, and surviving long enough to make the numbers undeniable. What the program could not teach itself, the bird taught it. Parish's field notes from those recovery years contain something the program's final reports did not fully quantify. The cost, measured not in dollars, but in individual birds grounded, treated, and re-released into the same unresolved landscape. That accounting, and what it ultimately forced the conservation community to confront about who controls the sky above the Grand Canyon, is where we go next. That accounting, the cost measured in grounded individuals, in veterinary interventions, in blood samples drawn from wings that should have been mapping canyon thermals, points you towards something the field reports never quite said plainly. What those 6 animals were doing to the landscape itself, at a biological level, was something no management model had thought to measure. Start with the mechanics, because this is where the story stops being policy and becomes pure physics. A condor locates a mule deer carcass from 150 meters of altitude. Its eyesight calibrated not to motion, but to the specific stillness of a large dead animal against canyon rock. It can sweep a search radius reaching 250 kilometers in a single soaring day, burning almost no energy in the process. Once it lands and feeds, the chemistry inside that gut becomes the critical variable. A condor's stomach acid runs at a pH between 1 and 2, among the most caustic biological fluids documented in any living vertebrate, low enough to neutralize botulism spores and anthrax that would sicken or kill every other scavenger that touched that same carcass. The carcass is stripped to bone within days. That speed matters enormously, because slow decomposition at canyon floor water sources leaches pathogens directly into the groundwater that every downstream species, including humans, depends on. The condor does not just eat. It closes a contamination loop that no other animal in that ecosystem can close at the same speed or the same scale. Think of the sequence as a 3-stage biological system operating every time a single animal feeds. The stomach acid destroys the pathogen load. The rapid consumption prevents groundwater contamination, and the scattered bone fragments deposit calcium into the immediate soil zone, a mineral cycle the canyon had been running at zero for 72 unbroken years. Within 3 years of the 1996 Arizona release, Chris Parish and his monitoring crew at the Peregrine Fund documented something the captive breeding models had not predicted. The animals were not moving randomly. They were mapping, identifying what field biologists call carrion corridors, the canyon routes where dead animals concentrate, where thermals cluster, where the search geometry made biological sense. You are probably wondering at this point whether 6 animals mapping a canyon system could genuinely change the landscape's disease ecology, or whether that claim is larger than the evidence supports. The answer is in the spatial data Parish's team accumulated across the following decade, and it is more precise than you might expect. Stay with this, because the numbers tell you something about scale that the biology alone cannot. By 2017, the wild population across Arizona and Utah had climbed to more than 80 individuals. 80 animals actively processing carrion along a canyon system that had run that entire biological function at zero capacity for 72 years. That is not a recovered species. That is a restored sanitation network with wings. The contrast between what the canyon scavenger network looked like at the moment of the 1996 release, 0 functioning wild individuals across the entire canyon system, and what Parish's monitoring documented by 2017 is not a gradual improvement. It is a structural shift in how the ecosystem processes biological waste at landscape scale. A condor is not a symbol, it is a mobile pathogen neutralization system with a 3-meter wingspan and a 250-kilometer daily operating range. And when you remove it from a canyon for 72 years, the canyon does not stay clean. It accumulates exactly the biological debt you would predict. What Parish's notes reveal about who still controls whether that debt keeps growing, that is where we go next. What Parish's notes reveal is not a triumphant straight line. It is a record of a species that had no interest in the recovery plan written for it, and a field team that had to keep rewriting the plan in real time to stay close enough to document what was actually happening. The models drafted before the 1996 release assumed geographically contained movement. Birds anchored near Vermilion Cliffs, drawing from supplemental feeding stations, available to monitoring crews on a predictable schedule, staying within the designated habitat envelope that had taken researchers months to map. Within 5 years, every single assumption in that model had been stress-tested and broken. Not partially, not in edge cases, but structurally across the board, in ways that forced a fundamental reassessment of what a captive-raised bird actually retains about its own species' spatial instincts. Parish's team started logging incursions near Grand Canyon Village, a populated rim area that the habitat suitability maps had classified as unsuitable. The birds landed on park structures, walked toward visitors without hesitation, and in at least one documented incident, methodically dismantled rooftop equipment with their beaks. The birds had no fear of people. None. Because no one had taught them to. Captive rearing had preserved the physiology, but not the cultural wariness, the learned behavioral distance from humans that wild-reared birds develop through direct experience in the field. Re-aversion conditioning, using mild aversive stimuli, had to be engineered into the program after the release, retrofitted into a recovery effort already 5 years in motion. You are probably asking yourself how a program that sophisticated missed something that fundamental. And the answer is coming, because it is tied directly to what lead kept doing to the population count while all of this was unfolding, and that answer changes how you read the entire recovery. Lead toxicity from ammunition in hunter-harvested carcasses kept pulling birds from the free-flying population faster than the models had projected. Each poisoning event triggering a veterinary intervention that pulled field team resources away from monitoring and delayed the flock's progress towards self-sustaining status. And yet, the population grew anyway, not because the obstacles cleared, but because the birds outpaced them, producing the first wild-hatch chicks in the Arizona-Utah region by the mid-2000s in cliff ledge nests above the plateau, in the same geological formations their ancestors had used before. Lead pulled the last of them from the sky. A reintroduction site had become a breeding ground, a designation no one had written into the original plan on a timeline no model had forecast, in a habitat that the suitability maps had treated as provisional at best. The birds had exceeded every projected boundary. What that cost to sustain, in resources, in policy, in the one cultural shift the program could not engineer around lead, that is what Parish's unfinished accounting reveals. Parish's unfinished accounting, when you sit with it long enough, resolves into something almost unbearably simple, a number, and what that number costs to reach, and what it still cannot claim to mean. In 1987, 22 individuals remained. Every wild representative of the species gone from every sky on the continent. The entire biological inheritance of a lineage 10,000 years deep, folded into a handful of captive enclosures in San Diego and Los Angeles. By the early 2020s, that number had grown to more than 500 individuals globally. Free-flying birds documented across Arizona, Utah, California, Baja California, and the Pacific coast of Mexico, soaring across a range that spans more than 2,400 kilometers of coastline and canyon country. Now, think about what that means for a moment. Every population model constructed in 1987 classified this outcome as statistically improbable within a single human lifetime. And the lifetime has not even closed yet. The distance from 22 to 500 is not a miracle. It is a pressure equation. Remove the thing that is killing a population faster than it can replace itself. return the minimum viable number to a functional landscape, and the biology does the rest. 500 is not a recovered population. The management requirement remains intensive. Veterinary intervention for lead exposure still pulls birds from the wild on a cycle that no self-sustaining species should require. And the ammunition culture that drove the original collapse has not fully changed. Chris Parish documented this tension in his Vermilion Cliffs logs with characteristic precision. The carrion cycle is still not fully repaired, and a population that cannot feed itself on uncontaminated carcasses without human supplementation is a population still held above the waterline by hands, not yet swimming on its own. The timeline itself is the argument. From the December 1996 release of 6 birds above the Vermilion Cliffs to a continental population exceeding 500 individuals, that passage covers less than 3 decades, a window shorter than the 72-year absence that preceded it. The sky did not wait to be convinced. It simply resumed. Drop your region and one species you have personally watched disappear from your area in your lifetime. And yes or no in the comments. Have you ever seen something come back that you were certain was gone for good? Because if the answer is yes, I want to hear that story. Share this with someone who still believes the damage is permanent, because the evidence says otherwise. In the next video, I am taking you to Yellowstone, where 31 gray wolves reintroduced in 1995 measurably altered the physical course of rivers. A geomorphological shift the U.S. Fish and Wildlife Service left out of every page of its 1994 environmental impact statement. A document the agency spent years defending against legal challenge while the landscape quietly produced the one outcome no model had anticipated. The question that still divides restoration ecologists: what a predator's second absence costs a watershed that has already forgotten what fear smells like. That is what we answer next. I'm Dr. Raymond Finch. I'll see you in the field.